Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 5.4.4 on derangements. So just like primitive bit strings were Saman solutions, derangements, whatever they are also Saman solutions to a cumulative sum counting problem. So let's see what that would be. Pretty much, sometimes a permutation on three things can really be thought of as a permutation on two things, or maybe a permutation on one thing, especially if some of the points are fixed. Like, here's an example. What if we had a permutation that did this, like 1 goes to 2, okay, and 2 goes to 1, then 3 goes to itself. So really, this permutation can really be thought of as a permutation on two things because one of the things is kind of ignored. And so derangements count what's left over after these guys are taken out. So kind of like what's primitive in a sense for permutations as we go up here, that it can't be considered as guys coming from these below. So it becomes a natural Saman type problem. Another way of saying derangements or defining them is simply saying just it's a permutation that has no fixed points, meaning that nothing is sent to itself. Everything moves. So that's what we'll be counting. So it's a natural Saman problem for the number of permutations that we have of each respective size. This is a power set structure. And we're looking for the Saman solution right at the top only here. So we can kind of think about on here. So we're going to be looking at so we want the Saman solution that comes from the top. So now each of these guys, okay, so meaning a standard basis element that has a 1 here and zeros elsewhere, for instance, this is going to have a contribution to the top. Which contribution is this one going to have to the top? Let's see, it's going to have a 1 because it's so 1, -1 in that level, and then a 1. If you think about a power set with a 1 here and zeros above it, the solution ends up being a pattern of 1s, -1s, and 1. So that's going to have a solution of 0, a solution of a positive 1 at the top. This guy's going to have a solution of -1 at the top. This one's going to have a solution of -1 at the top as well because it's an odd number away. Okay, so and so what we get is we get something like this: 3 factorial minus 2, because that counts how many permutations of a certain size. Minus all those, add all these, minus that one. Notice this one and this one are an odd away from 3, so they contribute a negative to that top Saman solution when you multiply it through. So those are subtracted and these ones are added because they're an even away from the 3. And so we get the number of derangements of size 3 is 2. All right. And we could actually see that these cycles right here are the only 2 derangements of size 3 written in cycle notation. Thanks for watching.